Welcome to this beginner-friendly guide to object-oriented programming, which is OOP. If you ever wondered what OOP is, or terms like classes, inheritance, polymorphism mean, you are in the right place. By the end of this video, you will have a solid understanding of the core concept of OOP. Let's dive in. OOP is a programming style that organizes software design around objects instead of just functions and logic. Think of it like building blocks. Each block is an object, has its own properties and behavior, and they can interact with each other. This makes your code more modular, reusable, and easier to maintain. Object-oriented is just a way of programming that you just orient a real-world object into programming and work with it. For example, think of a book. Book is an object. So how can you orient it into your code so that you can mimic the behavior of a book using your code? That's what we call object-oriented. So let's start with classes and objects. A class is a blueprint. It defines the structure and behavior of an object. For example, I mentioned a book. So before we created a book, we have to have the architecture of how the book will look like. That's what we call class in object-oriented. Class is just the architecture of how your object should behave and what data it needs to behave that way. So like I said, a class is a blueprint of an object. So an object is an instant of that class. For example, if car is a class, for example, we have the architecture. When I mention a car, you can just think of something that has 4 wheels moving forward or backward, and you can control it with a steering. But then specific car like a Tesla Model 3 is an object. Think of it like this. The class is the recipe, and the object is the cake you bake using that recipe. When you look at it as a home perspective, the architecture of your house is the class, while the house itself is an object. Next up, we have inheritance. This is where one class can inherit properties and methods from another class. For example, if you have a class called animal, which is the architecture of the animal object, then you can create a subclass called dog, and dog can inherit all the traits of animal, but also add its own unique features like barking. Inheritance help you reuse code and avoid repetition. We don't want repetition in programming. Now let's talk about polymorphism. I'm very sure you understand inheritance. Polymorphism, which means many forms, it allows objects of different classes to be treated as object of a common superclass. When I say superclass, it just means a parent. When I say subclass, it means a child. For example, you have a father and a mother, so they are a superclass, and then you by yourself, you are a subclass, which means you are a child of that superclass. So whatever behavior of that superclass have, you have to inherit some of them, and then you have your own behavior. That's what we call inheritance. And when you inherit some of those behavior, you're going to have your own unique behavior. For example, your parent, they are talk, so means they have a behavior of talking, and you too, you are talking. But when you making sound, when you are talking, the way you are talk is different from the way they are talk, but you both talk. That's what we call polymorphism. You both did the same action but in a different way. That's what we call polymorphism. Encapsulation is all about keeping your data safe. It is the idea of bounding data, which means attribute, and method, which is function, or we say the behavior of an object, that work on that data into a single unit. Like a class, It is also restrict direct access to some of an object component, which is a way of preventing unintended interference. Think of it like a protective capsule around your data. That's what we call encapsulation. Instead of just calling your object name and then change it, but if you encapsulate it, no one can change the name of that object. That's what we call encapsulation. Then moving on, we have abstraction. Abstraction is about simplifying complex system. It hides the unnecessary details and show only the essential feature. For example, when you drive a car, you don't need to know how the engine works. You just need to know how to use the steering wheel and pedals. Abstraction helps you focus on what an object does, not how it does. For example, you are a human being, so you don't care about when you eat food, your food will go through your esophagus, go to your stomach, do this, do that, and then jump into your large intestine and small intestine, do this. You don't care. What you just care is, you know that when you eat food, you're going to, later on, you will pop it out through your anus. So that's what we call abstraction. Just a simplifying a complex stuff into just look at it as a simple, smaller thing. Like your computer. You don't care how your computer is being built. You don't care that your computer is built with CPU, battery, motherboard. You don't care. What you do care is, when you buy a computer, it's supposed to do this, do that, and you just work with your computer, type this, do this, play game and whatsoever. You don't care about what is happening behind the scenes. That's what we call abstraction. If you find this video helpful, don't forget to like, share and subscribe for more programming tutorials. Thanks for watching and happy coding.